Oh, wow. Hey, my camera worked now. That's kind of cool. I guess I can leave that up. Alright, so you guys should be able to see my face now. That's kind of weird. But I'm done with it. Alright. Whiteboard. Let's put me over here. What up? This is like a workaround so you guys can see me. So we'll start. No. But I'm presenting, you still can't see it? What?
Mr. Lima had this issue, and
hang on, let me
we had Miss Frost, we had everybody.
You had the whole team in here.
The whole dream team. Always up with the team.
Boom. That really became a nightmare.
Wait.
Can you see me now?
Now, you can sort of see what is...
Can you see the whiteboard?
No.
Just the cover cam? What the heck?
I don't...
Hang on. See, yeah, Google's been acting super weird for me. Okay, you can't see me, but you can see the whiteboard in my camera. Okay, so sorry guys, you still can't see me. But I got my chat open. So if you guys online have questions or anything, let me know. Alright, so you guys that are in person, right, they clearly didn't think this through when bringing you back to school, because if you don't have a touchscreen Chromebook, I have no idea how they anticipate you doing math, right, because it's pretty stupid. So what I would do is, if you're good with your mouse pad, you can open up like a Jamboard or something and just kind of use your mouse cursor. I think the mouse pads on computers are real sensitive, so I suck at it. So what I would do to take notes is I would open up a Google Doc or like Google Keep and just like type things, and hopefully it makes some sense to you. But yeah, whoever decided to bring you back without touchscreen computers has never taught before. So you guys at home, luckily you don't have that problem. So let's get started.
I have a quick question. Does anybody have a touchscreen? Because I've seen a few students.
There's like a scattering of them,
Okay.
but it's not like normalized.
Did you get yours from RUSD?
Yep, and
Some of us
I got here 4 years ago, and that was the first thing I said. We need Chromebooks for everybody, and they should be touchscreen. And look where we are now. We got Chromebooks for everybody. They're not touchscreen. Okay, so equations. Super basic skill. In your life, you may not actually write out equations, although mentally we do equation math all the time. And it's just a skill that translates, and honestly, for every single math class you're going to be in for the rest of your life, you're going to have to know how to do this, so let's try to figure this out. So, 2x plus 4 equals 12. The goal is to get this x all by itself. We want to know what number we could put in for x to make the left side equal to the right side. So if you're good with numbers, you might be able to tell already that if you put a 4 in there, 2 times 4 is 8, 8 plus 4 is 12, 12 equals 12. I don't like doing equations that way because I like to actually work the math out, and when you get to more complicated stuff, it's actually pretty hard to do that. So we use inverse or opposite operations to make this happen. So anytime you see a number or a symbol, we have to figure out how to undo it, how to take what's there, do the opposite to it to get the x by itself. That is the entire goal of an equation. Questions? I think I told you guys this like day one of the school year. I assume if you're quiet, everything I'm saying makes perfect sense.
We did go over this with Mr. Lima.
With what?
We went over this with Mr. Lima.
Oh, good. So this is just hopefully just a little review.
A little refresher.
But equations, honestly, there's seniors here that are in like advanced math classes that are shaky on equations. So if you can work on this, you'll be straight. So let's go. The first thing I'm going to do is ask myself, do I want to get rid of the 2 or do I want to get rid of the 4? And the 2 is connected to the x by multiplication. The 4 is addition. We undo addition first. So to undo addition, the inverse is subtraction. We subtract 4 on both sides, and we always do it to both sides because we have to keep it balanced. You would not, trim one of your eyebrows and not do the other. You would not brush your left side of your mouth and not brush the right side of your mouth when you brush your teeth. You do things to both sides. Symmetry, keep it balanced. 2x equals 8. If I'm going too fast, let me know. If you have questions, let me know. Otherwise, I'm just going to keep rolling because I don't want to get my voice sore for unnecessary things. 2 times x, that is what this is, 2x. That's the coefficient, and this matters because you guys have, I'm sure, have seen this by now, right? This 2x looks just like that, right? So you can consider this is almost like slope. I'm not saying it is, but it can help you kind of start seeing what slope could be. Slope would be 2 over 1, positive slope. So I'm trying to sprinkle in as much graphing stuff as possible. I need to do math, bro. All right, divide by 2 because this is multiplication. Inverse is division. 2 divided by 2, anything divided by itself is 1, which is what we want. So we just want one single x all by itself. And that gets us 4. So like we said, this is the magic number. I'll use green for you, Schmidt. That if we put it in here, if we put a 4 in there, this makes the equation balance.
For n times 4 is 8 plus 4 equals 12.
Boom.
You can always check your work and see if it makes sense.
Always. Because you know what? That's one thing I think kids say a lot. This is stupid. This doesn't make sense. Who put letters in math? You don't got to have letters. You can take the letter out and put a 4 in instead. All right. Let's do another one. Bunch of negatives. Negative 5, negative 3x equals negative 17. I'm going to try to do a bunch of different things to, just expose you to the elements. So, same logic here applies. I'm looking at the side where the x is. I got to get rid of this negative 3. I got to get rid of this negative 5 because I want the x by itself. Can anybody tell me what I should get rid of first?
The negative 5.
Thank you. And how do I do that?
You add 5 to one side.
Yes, we do. Yes, we do. Now, technically, there is a way where you could get rid of the negative 3 first, but you're probably going to make a mistake in doing so, and it's going to make your problem messier. So we try to follow these steps. Don't make it harder than it has to be. So when you add and subtract the same number, it makes a 0. It cancels out. That's what we want. You get negative 3x, and if you owe somebody $17 and you pay them back 5, how much do you still owe them?
Well, negative 12.
You still owe them 12 bucks, exactly. I always try to think of adding and subtracting like money. It makes sense in my brain. Negative 3x equals negative 12. This is a one-step equation. Can somebody tell me how to finish this?
You divide both sides by negative 2.
Beautiful. Beautiful, beautiful. So we divide by negative 3. If you happen to forget the negative, you'll end up with a negative x, which isn't bad, but it's also not what we want to finish. So you have to divide by negative at the end anyways. So just do it right away. So x equals negative divided by negative is a positive. And look at that. I must like my 4s today because these probably coming out 4s. So these are two-step equations, very common. I'd say this is like the bare minimum that you need to know. I wouldn't call this a 2 level. This is like a little below 2 level. But this is where we should all be. So if you're not here, it's cool. I can help you. But we got to get here. So I'm going to move on to something a little different. Let's get some division going. And I know everybody just loves these division problems, right? For some reason, we all get scared when we see division. Like we think of fractions or something. There's no reason to be afraid of that. So, this is pretty much the same problem as before, where you get rid of addition or subtraction first, and then you get rid of the division instead of multiplication. So, to get rid of a 2, I train track it to keep me organized. I'll subtract 2 on both sides, and I get x divided by 3, and I get a 4 minus 2, which is a 2. And I have an x divided by 3, and to get rid of division, I multiply. So I put the entire side in parentheses, and that is because when later on there are problems where you need to multiply multiple terms. So instead of just putting like a times 3, we use parentheses. That's just good practice. So we multiply by 3 on the left, we multiply by 3 on the right. When you multiply and divide by the same number, you get x equals 6. 3 and 3 simplify to 1. That's 1x. That's what we want. 2 times 3 is 6. I'll pause 7 seconds for potential questions. Keeps my life interesting. Yeah, one of my professors would do that. We'd be working on stuff, and he'd be like, all right, I'm going to check your work in 39 seconds. And, like, kids always like to track time, and I feel like when you throw anything that's not a solid number, they have no idea what time it is, so they just keep working. Try it. It works. Like, we're going to come back in 2 minutes and 37 seconds. They have no idea. Their life is in shambles. If you said 2 minutes, they would have no idea either, but the 37 really just throws them for a loop. Or you'll get the kids that try to count 2 minutes and 37 seconds. Okay. Let's do one of these with some negativity in the mix. I'll let you guys write that down. Hopefully this recording saves, because I did this the other day, but I still have no idea where that video exists on my computer. So
The cloud. I love the cloud.
Remember when that first concept started and people were like so like freaked out by it? I don't trust the cloud. And now literally everything's on the cloud and nobody even thinks what's not on the cloud. Like my whole phone's on the cloud essentially.
Yep. I uploaded like all my music to the cloud too. Yeah.
Back in the days when you had to download your music.
And share,
LimeWire. But yeah, I didn't get into torrents until I was a little older. Pirate Bay. But yep, man, LimeWire. I messed up a couple computers with LimeWire back in the day.
Yeah, well, and then you would, like, especially with like dial-up, you have to do it at night.
And then like, somebody would call, the song would stop downloading with like a couple KBs left, and you have to find you guys don't know the struggle. For real. It would literally take like an hour to get a song. Like to get one song. And then you'd have to do that for 10 songs and then burn it on a CD. Those are the days.
Oh, for good old times.
For real. Yeah, and I'm just old enough where I got to do some of the recording of the tape cassettes off the radio too.
Oh, I did some of that, yeah.
That was always fun. Waiting for the song to come back. Waiting a whole day for a certain song. Alright guys, let's do this. So looking at this, the x is on the right hand side. I got to get rid of the -4 and the -7. What should I get rid of first? Correct. And how do I do that? Add 4 to both sides. When we do that on the right, we get a 0, which is what we want. On the left, we get 14. I was born on the 14th. That's maybe why I'm attracted to this combination of numbers here. All right. Now it's just a one-step equation. We got a 14 equal to a -x over 7. To get rid of this -7, we need to multiply by -7. If you don't multiply by -7, you're not necessarily done for, but you're still going to have a negative, and then you're going to have to do an extra step. And I don't like wasting my time doing unnecessary things. So on the right-hand side, the -7 simplify out. It makes a 1, and therefore it's just a single x all by itself, which is what we want. Hopefully your x is lonely for breaking your heart. Now, -7 times 14. Do the math. If you can't do that math, write it out. If you can't write it out, use a calculator. 7 times 10 is 70. 7 times 4 is 28. 70 plus 28 is 98, and it's a negative. That was smooth. It's been a while right now. I got these things just bouncing in my head. That's one of my favorite things about doing stuff with X's, because I just like, especially you guys are, I'm hopefully dating less than normal in this pandemic, but usually freshmen are getting their heart broken every other week, so I can just make kids like getting their feelings all the time. Pretty fun. All right, so we did two-step equations multiplication-wise, two-step equations division-wise. Show me a 1 to 4 with your hands in person and type a 1 to 4 on the computer on how you're feeling. 4 being this is super easy, you got this. 1 being this is super hard, I don't get it. 2, I kind of get it. 3 being I'm feeling pretty good, I could probably do most of this on my own. Where are we at? 1, 2, 3, or 4? Cool. If you're not feeling like the number you want to be, make sure you're asking questions. You could always go home and look up my equation videos and get some more help, but I would love to help all of you get to where you want to be. Online, looks like we got a bunch of 3s, a couple 4s. I'd love to hear from all of you, but let's keep it moving. So after we get out of the 2 steps, I like to do distributive property ones. Distributive property is something that's super important because I think this concept carries over well. And if you get into any type of like computer programming, there's definitely stuff that involves distribution. So we'll start here. So hopefully distributive property is not something that's scary. All it does is say instead of multiplying one thing by one thing, you're going to multiply this one thing on the outside by everything that's on the inside of the parentheses. So there could be 20 things in the parentheses. You multiply every single one by 3. That's all it tells you. I should probably make it a habit of showing you guys multiplication more than 2 terms because that definitely happens. So I draw rainbows, I draw the arrows, 3 times x and 3 times positive 1. You do each of those separately. If you forget to multiply by one of those terms, you're not going to have the right answer. 3 times x is 3x. 3 times 1 is 3. Bring that down, we got 9. Should have made that a 2 and we could have 3, 6, 9. Now it's just a 2-step. We just did a whole bunch of 2 steps. So hopefully everything that we did in the last couple problems is clicking now. I'm going to add one more step every time, but this should feel really good at this point. So hopefully you're like, yeah, I got this. I'm going to subtract 3 on both sides. This is a 2-step. I got to undo my addition. I got to undo this multiplication. I know I can do that by dividing, so I divide by 3. And my x is going to be 2. And the x tells you this is the number that makes the equation balance. And this matters. So let's say, you know, in real life, you're like, should I pay for this rental car or this rental car? This rental car is $200 a week. This rental car is $300 a week, but I'm driving 1,000 miles. This car gets 25 miles a gallon. This car gets 15 miles a gallon. You can literally do the math and figure out which one is going to do, which whenever I drive to Florida, I don't like using my own cars. I like to rent cars, so I do the math and figure out how much gas is going to cost me when I'm figuring out which vehicle I want to get. We good? Okay, I'm assuming we're good. So let's do another one. Let's throw a couple negatives in the mix here.
That's where I get messed up.
The negatives?
Yeah.
Alright, alright. Let's do...
So this would be an example like PEMDAS, right?
Yes. Yes, exactly. You're using PEMDAS before you undo PEMDAS, because I think of solving as undoing it. So you're doing it so you can undo it.
Is that not?
No, you know. The people that made these math theories definitely weren't the most normal, sociable, average human beings. They definitely wrote things in complicated ways. Which is why I think I'm a pretty good math teacher, because my brain is definitely more normal than not. Usually.
Who defines normal?
I do. I think, so here's my definition of normal. Normal is if you can connect to the majority. Even though that's always not a good thing.
We've all had those professors that were just like so smart they were dumb.
Yeah, and like, this is a stereotype, and I don't necessarily believe it, especially at the school. However, I think that carries to a lot of even high school math teachers, or middle school math teachers. People in math and the sciences tend to just be a little more to that spectrum. But yeah, college was rough. Okay, this has a lot going on, so if you're struggling to keep up, let me know where you mess up. But you'll notice this is a double distributive property. There's distributive property on the left, there's distributive property on the right, and as Mr. Schmidt said, we use this as like PEMDAS, so we're first doing it to make it less messy, and then we're going to use it to solve it. But if you can't solve this equation, if the parentheses is still there, so we have to get rid of them. So we're going to do that here, and we're going to do that here, and we're going to do that here, and we're going to do that here. So this negative 2 is just there. Nobody cares about it yet. And on the left, we have a 5 on the outside, a positive 5, and we're going to times that by x. We're going to times that by negative 2. So we get a plus 5x. We get a 5 times negative 2. That's going to be a negative 10. On the right-hand side, and this is potentially messier, so let's make sure we're careful. I think negatives are always a sign where people make mistakes. I make mistakes if I'm going too fast. We have a negative 3 outside, so we're multiplying everything by negative 3. Inside, we have a negative 4 and a negative 3x. So let's go slow. Let's do negative 3 times negative 4. I know, and you should know if you don't write it down, that a negative times a negative is always positive, every single time. So a negative 3 times negative 4 will be 12. Positive 12. You don't have to put the plus, because a number without a sign is assumed to be positive, just like people assume everyone you meet has good intentions. Now, a negative 3 on the outside times a negative 3x on the inside. You multiply the negative 3 times the coefficient, which happens to be negative 3. Negative 3 times negative is a positive, and 3 times 3 is 9. I will pause in case anything got you lost. If you can do that, you understand distributive property. How's my speed? Am I going at a good speed for you guys? Am I going too fast, too slow? Just right? Porridge ain't too hot, ain't too cold. How about online? How am I going for speed? Too hot, too cold? Where are we at? Gotta drink my oat milk iced coffee. Anybody online, let me know. How's my speed? Are we good still, or am I going too fast, going too slow? Kaylee says I'm good. Kaylee, I trust you, so let's rock with it. Alright, on the left-hand side, I have 3 terms. 1, 2, 3. 2 of them are plain numbers. They're constants. That means you can put them together. You guys have learned to add a long time ago. You have learned to add when you were a little kid, when you realized that 1 piece of candy plus 1 piece of candy is better than just 1 piece of candy. So, negative 2 combined with a negative 10. Think about negatives as spending money. You go to the store, you spend $2, and then you spend $10 more. How much did you spend?
12.
So that means you have $12 less than you started with, so we have a negative 12. That 5x, nothing happened, just bring it down. And on the right side, you cannot combine a 12 and a 9x. This is a common mistake that people make. You can only combine things that are the same. Apples and oranges don't make anything. It just makes apples and oranges, unless you're talking about fruit. 12 plus 9x is not 21x. It's not anything else weird. This is just 12 plus 9x. Please don't mix up your numbers. Please don't mix up your x's. Now, on the left, I have a number and an x. On the right, I have a number on the x. The goal is to have all our x's on one side together. So we need to move one of the x's to the other side. Personally, I always try to move the smaller x. It's less work for me because it happens to usually stop me from getting any negative numbers. So instead of having a 5x over here and a 9x over here, the 5x is smaller, so I move it with subtraction. If you're not sure about this, please write a note right now that to move an x from one side to the other, you add or subtract it. To move an x, you add or subtract. To move an x, you add or subtract. That's something that you should all know. Some people try to divide them, multiply them. That's not going to work. You add or subtract to move the x. On the left-hand side, these x's cancel out, right? If you have 5 x boxes and somebody steals all 5 x boxes, you only have 0 x boxes. 12 plus 9x, that's one thing. I thought I was going to play some video games while I was on break. I did not play my PlayStation one time. My daughter turned it on to play some Rock Band once. That's about it. Okay. We're getting to the end. I'm running out of room, so I'm going to move this over here. Sorry. Negative 12 equals 12 plus 9x. So we're over here now. We moved. I got to get the x by itself. The x is on the right-hand side, so I got to move the 9. I got to move the 12. I'm going to move the 12 first by subtracting it. Negative 12 minus 12. What is that? Think of it like money. You're spending money, you're spending money.
It would be negative 24.
Negative 24. If it was a positive 12, it would be 0. But negative, you lose $12, you lose $12. You swim 12 feet underwater, you swim another 12 feet underwater. At that point, be careful, because I think you could blow your lungs up coming back up. Probably not till past 30 feet, though. 12s cancel out on the right, because one's positive, one's negative. And the 9x comes down. So you might be thinking, I know for a fact 9 and 24 don't divide evenly. And you'd be correct. But that's okay. Numbers in life are messy. You know, gas is not $1. Gas is not $1.25. Gas is not $2. It is like $3.49 and 9/10 of a cent.
I always hated that.
I really do.
0.9.
Like I want to know, like, what's the logic? Like, is it just because they can, like, skim off fractional pennies on the profit? Like, what is the reasoning?
That's the way they do it. People resist change.
That's a big fact. Because I know banks truncate your money. So, like, when you do transactions, like, you might be spending, like, $0.0213. They truncate that 0.13 and they keep it. So banks make millions of dollars every year keeping your, like, money that's less than a penny.
Let it happen quickly.
Yep. Speaking of less than a penny, I don't know if any of you guys follow Dogecoin. I had $500 of that in July at like 0.2 of a penny. Ask me how upset I am that I don't have $60,000 right now because I sold it before it went up. Highly upset. Yeah. It's like a meme coin. And it was like, in summer last year, it was like 1/3 of a penny. By like around the Super Bowl, it hit a penny. Or no, New Year's, it hit a penny. And then by the Super Bowl time, it went up to like 7 cents. It was kind of fluctuating around 7 cents. And then mid-April, it went up to 42 cents. And now it's at like 70. So if I would have invested $1,000 on New Year's, I'd have $70,000 right now. If I would have just left my $500 in there, I'd have like $70,000 right now, $60,000 right now. Highly upset. All right. Divide by 9, divide by 9. Negative 24 over 9 equals x. This could be your answer. This could be your answer. However, I like to simplify my fractions whenever possible. 24 and 9 have a number that's in common. What number is that? What number goes into both of them evenly? 3, exactly. So we do 24 divided by 3 and 9 divided by 3. That's called simplifying your fraction. So you divide the top by 3, that gets you a negative 8. You divide the bottom by 3, that gets you a 3. That is your answer. Now I want to make a connection here. What if I wrote this instead? And I'll highlight it in green. What is that? What would that be in math? That would be slope. M represents slope. So if that was your slope, what does that tell you to do? How do you get to the next point with that slope? What does that slope tell you to do?
You rise over run.
Rise over run. And rise tells you to go up or down, and run tells you to go to the right. So what would the rise be here?
You would go down, you would go down 8.
The rise is negative 8, so we go down 8. That's what that negative 8 on the top in the numerator says, down 8. And then the run is 3, so you go to the right 3. That's what that slope means. That's a negative slope. So to envision what a negative slope looks like, take your left hand, put it up in the air on like an angle. Put your right hand towards the floor on an angle. Left hand up, right hand down. That's what a negative slope looks like. Imagine like going downhill, like you're sledding. That's a negative slope. Hopefully everybody that's remote, you're doing the same thing. When you see a negative slope, know that you're going to go down and to the right. You're going to go down and to the right. Is that familiar? We talked about sloping here when I was gone? Beautiful. How are we doing? We've been doing equations for 30 minutes. Do you want me to keep going? Do you want to do some stuff on your own? Can your brain handle more? I'm ready. It's up to you. Let's vote. If you want me to continue, give me a thumbs up. If you're remotely and you want me to continue, put a 3 in the chat. Actually, put a 5 in the chat. Put a 5 in the chat if you want me to continue. If you want me to stop, just say stop. Hands. What did I say for you guys? I don't even know what I said. Thumbs up.
Several numbers, so I'm kind of confused.
Same. Put a thumbs up in person. It's this whole 2 different people. I'm talking to 2 different groups of people. Okay, I'll keep going. Online, they want to keep going too? Let's go. Alright, so we did distributive property. Let's do another one that involves, where's my mouse? Let's do another one that involves some x's on both sides. Let's do negative 7x plus 2x minus 1 equals 2. Oh, this is fun. Alright. Get this down. What's up?
Can we ask for a volunteer to come off the Is your cool
the little pen thing?
pen thingy?
Yeah, I'm down. Would anybody like to do that? Am I going too fast? This is our first date in like 2 months. Mr. Schmidt wants to do it.
Oh, come on. All right. See if I pay attention in college.
Where's your pen? It's right there. Oh no, I think you got to do it on the actual. Or I don't know how to write on the smartboard, honestly.
Isn't there
There should be markers, but who knows where they are? Oh yeah, there you go. Ooh, that's super fat though. Oh, click. There you go. Click on the go down a little bit, and that green. It's green right now. The little pencil tool. Like, see the mouse icon?
I am just messing everything up. Why can't I undo this?
Click on the eraser towards the bottom. There you go. There we go. There you go.
I am failing. Okay, so this is what I want.
Yeah, that's what you want. So now I don't think this is gonna. Oh, you made it super fat. This isn't gonna show up for you remote people, so I'll do it again. But I'll just kind of talk through what he's doing.
It should show up.
I don't think it will.
All right. I try.
You got to adapt.
Adapt and overcome.
Alright. Is there a way to move this thing? What thing?
Oh, there we go.
Oh, so no, you write it on here.
Really?
Yeah. So I didn't like writing on the monitor because about that thing. What's up? So I'll annotate or commentate. So I'm seeing that Mr. Schmidt decided to do distributive property on the right-hand side. So he multiplied 2 times 3 and 2 times negative x. And now it looks like...
I should have did the combined like terms, huh?
Yeah, but you don't have to. You're still good. So now he decided to avoid combining like terms on the left, which I would have done first, but it's okay because he's adding the 2x from the right to the left. So he's trying to get all his x terms on the right. So he did that, and now he has negative 7x plus 2x on the right-hand side. Oh, you made my 1 and 7? That's cool. Go back up real quick and change those 1s from the original problem to a 7.
Where?
2x minus 1. Because you added 7, right? Yeah, make that 7. It was originally a 1, so that's cool. Okay, so now he's deciding to get rid of the constant. So he added 7 to both sides. And he still has two x's on the left-hand side that he's going to have to work with here.
This is really weird.
Oh, wait, how did you get 6? Oh, I'm confused.
Here?
On the left. How is it 6 equals 13?
Oh, I thought that was a -1.
Yes, yeah, it was. With that. So why
A
did you
-1
have
plus 7 is 6.
Why did you have 7, though? That's why I thought you read it as a 7. I thought you were adding 7 to cancel it out.
Can I go back?
Uh,
I'm failing.
Right, yeah, on the left-hand side, I think there's a...
Is there like an undo?
No, don't hit that one. Right there. There you go. See, we all struggle. It's good modeling.
Okay. So this is okay. So that's 7 plus 2x minus 1 equals equals 6. And you combine like terms.
Yep.
This is not going to come out pretty. That still doesn't look right.
So you added 1.
6.
No, that's good. You're doing it right. It's not going to be... I just made this problem up, so it's probably messy. But
Okay. Then we would just divide.
I'm trying to get messy numbers so then they can think of slope. You divide it by 3 or by -3? Because you can do either, but if you don't do the negative right away, you got to do it second. So it looks like the x is going to equal...
Yeah?
Correct. Is negative, right? Yeah. So you can do that. Personally, I don't write my answers in mixed numbers because I think mixed numbers are confusing. But that definitely works. Thanks for our volunteer coming up.
Oh, man. Sorry about that. I've never played with that before.
It takes a little bit to get used to. So if you would have wrote the number as... If you would have just kept the answer as x equals -7/3, that's also correct. Both of these work. You do whatever one works for you. Personally, this is where I go because I can relate this to slope very easily, right? This would be a negative slope. What would my rise be? And you guys online can definitely feel free to respond as well. That would make it a -7, right? So we're going down 7 to the right 3. You technically could do it with this, but you'll probably get yourself confused. So depending, if you're just solving it, go ahead and do the mixed number if you like, or do the improper fraction, whatever your brain tells you is more comfortable. Okay. I think that brings us to, first of all, let's see what time it is, because I don't want to overload you guys. So I think we got time for like 1 or 2 more. We'll get some division, a little more complicated division though. So something like this. If you get a division problem like this, it's important to realize it's different from the ones that we did at the beginning, because with these ones, it's a whole numerator divided by 5. It's not just one number. So it's 3x minus 2 all divided by 5. That means it's trapped. It's trapped by division, and you can't mess with it till you get rid of the division. So there's 2 ways to do this. People tend to make mistakes because they don't realize how much they're supposed to multiply. So I'm going to show you my way first, and I'll do one messy. So for this, I'm going to get rid of the +1 first. I like to get the extra stuff out of there so I can focus on the beast. And the beast in this case is the division. 3x minus 2 divided by 5 equals 1. 3x minus 2 divided by 5 equals 1. To get rid of this division, I multiply. Now it's important, like I told you before, to use parentheses. We use parentheses because we're going to multiply everything on the left by 5 and everything on the right by 5. Don't assume it's just one number that you're multiplying by. It might be a couple things. So 5, you could distribute it out to the numerator, but that's just a waste of time, because if you remember, a 5, when you divide by 5 and multiply by 5, it simplifies out. It's gone. It makes a 1. So we get 3x minus 2, and on the right we get 5. So I want to pause. I feel like I'm talking a little faster. Coffee's starting to kick in. What questions do you guys have about this first steps? Okay. At this point, this is just a two-step equation, right? We've done these. This is like the 7th one we've done at this point. We're going to add 7, or look at me, giving you the answer. Right? Add 2 to both sides. We get 3x equals 7. Divide by 3 on both sides. X equals 7 over 3. And I'm going to start going a little faster when we get to the 2 steps, because we've done a bunch. I'm assuming we can 2-step by now. So, multiply the whole side. That's the lesson here. Let's do another one, and I'll do it the messier way so you can see what it might be like if you do it, if you don't remember to follow the correct steps all the time. And that's okay. Everyone dances to their own beat. So, if we had something like this. Actually, I don't want to do 31. That's too big of a number. That'll make a mess. Let's do 9. Let's say you forget to add subtract the positive 3. Personally, that's what my first step would be, is get rid of the 3. What if you're like, I got to get rid of this division, it's bothering me, so let's multiply. Don't just go like this and multiply that by 4. That's wrong. You have to multiply everything. The whole side and the whole side by the division number that you're trying to get rid of. So on the left-hand side, you're going to multiply it here and here, which is different from the last time you just multiplied it to one spot. On the first term, you're going to get rid of the division, right? 4 times 4 and timesing by 4, dividing by 4, simplifies to 1. Great. 5x minus 2 comes down. We're all good. Then over here, 4 times 3, that's 12. So the difference is you're multiplying 2 terms, not 1. Over on the right, we get 9 times 4, we get 36. So from here, this is technically a 3-step, but it's just like a 2-step. You combine like terms. You got 2 bad guys, 12 good guys. They fight, Revolutionary War style, line up and just shoot at each other like idiots. And the 2 bad guys kill 2 good guys. The 2 good guys kill 2 bad guys. We got 10 good guys left. Drop to 36. That's a 2-step. I'll just quickly do this, but I'm not going to explain nothing. And that's going to be 26 over 5, which personally I'll leave alone. I'm going to do one more problem before I give you guys an exit ticket that needs to be done either today or before class tomorrow, so I know where you're at with equations. Let's have a little messiness with this one. Okay, this is going to be tons of fun. I hope you're ready. Sharpen your pencil. Get ready. All right. Left-hand side, I see division. I see an x term. Right-hand side, I see distributive property. I see division. It's important that you go step by step in this case. Now, you could do it a different way than I'm going to do it. Personally, I'm going to try and do this clean. First thing I'm going to do is distribute, because I know I can make that into something I can work with. Parentheses kind of hold up the work. Now what I see is I see division on both sides. That can be scary. You could 2-step it, or you can 1-step it. Personally, on this one, I'll show you how to 1-step it. Ask yourself, what is the least common multiple between the 2 divisors? 3 and 6 both go into what number? 6. Right? You can put 3 into 6, you can put 6 into 6. So if you multiply everything by 6, you can make this nice and clean. So we're going to multiply the entire equation by 6 over 1. And I'm setting it up as a fraction because when I multiply fractions, I multiply straight across. So I need my numerator and my denominator. 6 over 1, we multiply it here. 6 on the top, 1 on the bottom. Right? In this case, personally, I would just cross the 6's out. But I'm going to show you how to do it the longer way in case this is confusing you, because I'm purposely doing a messy problem. Negative 3 times 6 is negative 18. Negative 7 times 7 is negative 42. X comes along. 1 times 6 is 6. You didn't have to do that. You could have just cut the 6's, but I'm going to show you. And then we multiply this 6 over 1 times 2x. Well, the 2x isn't written as a fraction. You can make anything a fraction by dividing it by 1. 2x, negative 2x times 6 is negative 12. X, and 1 times 1 is 1. Do I have to write it? No, so I'm not going to, but I could. Equals, on the right-hand side, let's go ahead and distribute the 6. 30, oop, that's not a 30. 30x plus 30 divided by 3. I may need to make a new screen at some point. It's a lot, right? So let's simplify it out. Let's do the 18 divided by 6, and 42 divided by 6, and 30 divided by 3 to clean this up. Negative 18 divided by 6 is negative 3. Negative 42 divided by 6 is negative 7, which you can see is right there, right? So if you would have just cut the 6's, like I said, you wouldn't have had to do that. Negative 12x equals 10x plus 10. How are we feeling? This is ugly, right? You're probably never going to have to solve a problem this messy. But I'm trying to show you that if you just keep doing the same steps that we've been doing all day, it doesn't matter how many terms are in the problem, how ugly it is, you can figure it out. Left-hand side, let's combine these. Right-hand side comes along for the ride. That's getting messy, but that's 10x plus 10. Let's get rid of this negative 19x by adding it to the other side and this side. Negative 3 equals 29x plus 10, and I know I'm going kind of fast, but I was trying to finish at 45 minutes of recording, and we're at 47 minutes. It's been a long, long session. This is 2 steps, so at this point you should be like, yes, I got this. This is easy. I can do it. And then we divide by 29 to finish, and we have an ugly fraction, but that's okay because that allows us to speak about slope. And x is equal to negative 13 over 29, which if that was your slope, you would be going down 13 and to the right 29. So let's see if I can save this.